Hi, my name is Indira and I'm working on MovieLens dataset and I'm doing collaborative filtering, both item-based and user-based. I have imported the data and did some exploratory data analysis to save some time, and I'm directly jumping into merging of the two datasets. One is that of the user and the other one is that of the movies. So I'll start running this part of it and then a little bit of exploratory data analysis, and once I am done with that, I'm going to get a data frame in such a way that my rows are user IDs and my columns are movie titles. This is how it looks like with so many NaNs in it, not a number in it. So I cannot work with it further in order to find any cosine similarities or any mathematical operations on it. So that is the reason I initially replaced all those NaNs with zeros, but eventually I normalized it so that I can find the cosine similarities and take it from there. So now I have arrived at this kind of data frame where all the values are normalized. Now I'm going to find the similarities, and since I'm interested in finding the similarities between movies, I will have to transpose this data set since all my movies information is in columns and users are in rows. So that is the reason I'm going to transpose this data while finding the cosine similarities. Now I'm making sure that my columns are user ratings and my rows are also user ratings, so that is the reason they can be so readable and show their similarity values in the cells. So now I have defined this similarity of movies so that I can put the output in a descending order by making this ascending as false, and I will get top 10 movies here because I have asked for head 10. So since I put it in descending order, I'm going to get top 10 movies that are similar to the rating of this movie over here, name of the movie, and 3 is the rating of that movie. So similar to that, I'm going to get 10 movies that are similarly rated. Now that helps me recommend movies to any user. So this is another example for that, another run with another example. Now I have downloaded this test set also from the same grouplens.org. That is the reason I did not even divide or split my data into training and test data set. I can directly work on this test data set. And I did the same thing as the previous data frame, that is replacing all NaNs with zeros and then normalizing the data so that I can work with it further. I have all these NaNs in it. I'm filling them with the zeros initially and again normalizing them here with this definition over here for normalize. I'm normalizing them, and this is the data that I have got with all normalized values. Now I am going to give some test users information with these pieces of information that deal with the similarities, okay, of the movie ratings. Now based on that, when the output is also again arranged in descending order, I will get top 5 movies that are rated similarly. Now I'm trying to get user-based similarities. Item-based similarity is very easy to implement. Now it is user-based similarity. I am using this data frame from the standardized one, and in this case I don't have to transpose the matrix because my users are already in rows. Now I have defined this And here I'm asking the program to print me out user number 3 who has rated 0.086. I'm asking similar users to that user, and I have arrived at these 5 users who are similar to user number 3. This is similar users to user number 3, and these are similar users, top 5 users to user number 15. This is how I have arrived at similar users from this user-based collaborative filtering recommender model. Now this model evaluation is done in R, and I'm attaching that file also, and if I'm fortunate this will run, otherwise I can just submit this. Yes, it is running. So I have again downloaded this movie. I'm sorry, I did not download it. This movie lens data is from within this R environment. So that is the reason it has become easy for me to evaluate the models here. So I'm asking for only 10, top 10 movies. Now I'm evaluating it with 4-fold cross validation. This is the IBCF, which is item based collaborative filtering and recommender item based model on the trained data set, and here I am predicting, I'm building the I'm testing it on the test data set, which is prediction of item based, and I'm in this case here in this step I'm measuring the accuracy of the model, and this is where I have arrived at. I have got all 3 different measures. One is RMSE, MSE, and the other one is MAE. MAE was the one that we were targeting actually, and I'm building confusion matrix. Yes, here I get precision and recall values, and I'm also trying to plot them, and here this is what you can see in precision and recall plot. And in this situation here at this position, what I'm trying to do is I'm trying to see 5 or 10, 5 and 10, and after a while 15, 20, 25 in increments of 5. I'm getting that many nearest neighbors, and see how the precision and recall varies. So here what I see is the user based and item based. When I compare, surprisingly user based model is working much better than item based. Usually we will be under an impression that item based collaborative filtering is much easier, since the users are always comparatively in larger numbers than that of the movies. But this is what we have arrived at. User based is surprisingly performing well than item based. Thank you.